basic networking interview questions. I will cover layer 2, layer 3 and ARP in this session. Also we will do some scenario based questions related to ARP. So ARP related questions are the favorite interview questions, especially in Cisco, in Google, in Amazon. Okay, because without an ARP, the communication will not complete. Okay, so they want to understand how the ARP works in the layer 2 and the layer 3 environment. Okay, so before we understand what is an ARP, we have to understand what is layer 2 and layer 3. So let's start our session 2 on basic networking interview questions. Okay. So I said before you go to ARP, you need to understand what is layer 2. So when I say what is layer 2, it means all the machines are in the same subnet. So how do you understand? How the machine will understand that they are in the same subnet? So basically, using the IP address and the subnet mask, the machine comes to know to which subnet it belongs to, and the packet that it is receiving, it is for which IP address, and it is from which subnet. Okay, so when you say layer 2 means all the machines are in the same subnet or in the same LAN. Okay, if you want to give an analogy in the practical life, you can say, or if there are more than 2 people inside a same room, okay, then you can call it as the same subnet. They are in the same room. Okay, so to speak to each other, they don't have to cross the boundary, they don't have to go to another room. If they want to speak to each other, they can directly speak to each other. Okay, so that is basically a layer 2. So if you remember the OSI layer that I had explained, MAC address works on layer 2, correct? Layer 2. So if a machine has to speak to another machine inside the same subnet, what it will do, if suppose it knows the IP address and the MAC address of another machine, then it will directly do the unicast. Or example, inside a room, if 2 people want to speak to each other, and if they know where the other guy is located, he will simply go and speak to him directly. Okay, it will be a unicast. But if the room is crowded, there are many people inside a room, and if person A wants to speak to person B, and he doesn't have any idea who is the person B, so what he will do, he will broadcast, correct? He will shout that I want to speak to person B, and may I know who that guy is. Likewise, he will broadcast. So same mechanism happens in the networking world as well. The machine broadcasts, I want to speak to this guy, the guy having this IP address. Okay, now as I told you, layer 2 only understands the MAC address. So basically, if you want to do a ping from machine A to machine B, you don't do a ping to the machine B's MAC address. You do the ping to the machine B's IP address. Correct? That IP address has to be resolved to a particular MAC address. That resolution is done by the ARP, address resolution protocol. So IP address is what? It's a logical address. It's not the actual address or the physical address. As if you remember in the OSI layer, I have explained the MAC address is made up of 48 bits. 24 bits is the vendor bit, and 24 bits is the actual physical address of the device. So every IP address has to be mapped with the corresponding MAC address. Without this mapping, the communication will not complete. This job is done by the address resolution protocol. So basically, ARP, what it does, it maps IP to MAC. So in the layer 2 environment, when machine A wants to speak to machine B, okay, and it doesn't know how, it has never communicated to machine B earlier. So what it will do, it will send a broadcast, or it will send a ARP broadcast. So what does the ARP broadcast? initial first our broadcast packet will have, it will have the machine A IP address, correct? It knows it will have the machine A MAC address. It also knows machine B IP address, right? Because when you are trying to do ping, what you will do, ping machine B IP address. For example, here machine A IP address is 10.10.10.2 and machine B IP address is 10.10.10.3. So when you do ping 10.10.10.3, that means you know the destination IP, but you don't know the destination MAC address. So what you do inside a room when you don't know how to reach that person or who that person is, what you do? You shout, you broadcast. Okay. So what in the environment, in the networking environment, it will broadcast. Destination MAC address will be all SSS. Correct. So what happens? This is a machine A, and suppose machine A is directly connected to machine B using a Cat6 cable, machine A and machine B. What will happen? The broadcast will directly reach to machine B. Machine B will respond back. Okay, it will respond back. So what it will have? Machine B will respond back. The source IP address of machine is 10.10.3. Source MAC address of machine B will be, for example, here it is 0000.000.000.000A. Here it will be 0000.000.000B. Okay, and what will be the destination MAC address? This is now the source. Now what will be the destination? Destination A IP address will be 10.10.10.1 and destination B MAC address will be So what do you think? This is a broadcast or this is a unicast? This is a unicast. This was the ARP broadcast. This was the ARP response, which is unicast. Okay. Now each machine ARP will have what? Will have the information of machine A will have the IP address of B and its MAC address, and machine B will have IP address of A and its MAC address. Correct. So both the machine will have each other's IP address and MAC address, and now they can communicate. So until this ARP entry is timed out, whenever A wants to speak to B next time, it won't be a broadcast, it will be a unicast, because that information about the IP address and the MAC address is already stored in the machine's cache. Correct. So that now you don't have, the ARP need not do the address resolution protocol, as it is already done and it is stored in the ARP cache. So this is one scenario where machine A is directly connected to machine B. But is this going to be scenario in production environment? No, it won't be like this, correct? So how it will be like? Okay, let's go ahead. In production environment, what will happen? There will be a layer 2 switch and two machines will be connected like this. Machine A and machine B. Now what will happen here? Machine sends a broadcast, correct, for machine B. So basically machine A will the ARP broadcast will have following information: source IP address 10.10.10.1, source IP address of machine A, right? Destination IP address of machine B, source IP address of machine A. And destination will be again what? Destination MAC address will be again FF, 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 correct? This will be the our this will how the our broadcast look like. Now when the packet reaches a layer 2 switch, so what will layer 2 switch do? Layer 2 switch will create a MAC address table. And what it will do? It will store machine A MAC address and port. Suppose it's port number 1. And what it will, the layer 2 switch will do, it will forward the broadcast to all the ports except the port 1. That broadcast will reach machine B, and machine B will again respond back, correct? But just like in the earlier case, machine B has all the details now. Machine B knows the IP address, the destination IP address of the machine A, the MAC address of the machine A, the source, its own IP address and its own MAC address, okay, and it will respond. Our broadcast will receive an ARP response, unicast response. So layer 2 switch, so machine B when responds back with ARP response, what information it will have? Machine B IP address and MAC address, correct? And the destination, that is machine A IP address and MAC address. Again layer 2 switch will intercept that response and it will store the MAC address of A, of B and port number. Machine A will receive the response and the communication will be completed. The machine A will, like in the earlier case, it will store the machine B's IP address and the MAC address in its cache, and machine B will do the same thing. Whereas in layer 2 switch will also maintain the MAC address table. So next time when machine A wants to communicate with machine B, it will be a unicast. Layer 2 switch will look at its MAC address table for the resolution, okay, hence it will not forward the broadcast. So the next time the communication will be purely unicast. So first time the broadcast will happen, but second time there will be no broadcast. Okay, so that is how the layer 2, that is how the ARP works at the layer 2. Okay, so that's it. We are done with this. Okay, now let's understand how the ARP works at layer 3. So before we understand how the ARP works at layer 3, we need to understand what is layer 3. Okay, now what is layer 3? If you remember, when we discussed the OSI layer, we discussed about the layer 3, but that is the network layer, correct? And what was so specific about the network layer? One is the data unit at network layer is called as packet, and it follows the IP addressing schema, correct? So when we say layer 3, that means a machine from one subnet wants to speak to a machine in another subnet, okay? And layer 2 only understands MAC address, so layer 2 device is not helpful for a layer 3 communication. So we need a layer 3 device. So that layer 3 device can be, most likely it can be a router or it can be a layer 3 switch, okay? Layer 3 switch is nothing but a switch having a layer 3 capability, which can understand the IP addressing, okay? So it comes under the VLAN, inter VLAN communication. We will cover the VLAN in the subsequent topics, but later we will discuss about the VLAN. Okay, so right now we only go with the layer 3 concepts. Okay, so for example, now let's see, here we have a router A, and then that router A is connected to router B. Okay, and here we have a machine A, and here we have another machine B. Okay, now when machine A wants to speak to machine B, this has IP address of 10.10.3, this has IP address of 20.20.20.3. When machine A wants to speak to machine B, it has to cross the layer 2 boundary. It has to cross the layer 2 boundary, so basically it has to cross its own subnet. So we need a layer 3 device, and A and B are the routers which will act as a layer 3 device. So now when ARP sends a ping to 10.20. So when A sends a ping to 20.20.20.3, so it sends an ARP request or ARP broadcast. So what it will have? It will have the source IP as IP address of A, 10.10.10.3, MAC address of A, which will be 0.0.0.0.0.0.0.0.0.A, and destination IP of B, which will be 20.20.20.3. Destination MAC will be what? Broadcast, FF, correct? So when the router A receives the broadcast, what it will do? It will proxy the ARP. What it will say to A is, okay, I have received your broadcast, but I cannot forward this broadcast. What you do, you accept my LAN interface MAC address as a MAC address of B, okay? So it will replace this with 0.0.0.0.0.0.0.1A, okay? Okay, it will say make this accept my MAC address as a MAC address of B, okay? And then I will try to resolve. I will try to reach out to B. I will try to do the routing for you. Okay. So what A will store the MAC address of default gateway of the router A in its cache. Okay. Now A will stop this broadcast here itself at the LAN. Okay. Now this scenario that what we are considering here, we are considering without routing protocol. That means there is no static route or no OSPF, no EIGRP between A and B. So it is purely using the ARP. Okay, but in practical scenario, you will not see such kind of scenario. In practical environment, you will not see such kind of scenario. Okay, it is just for explanation of ARP. I am giving you this kind of scenario. Now, since there is no routing protocol, so router A, to know how to reach router B, what he will do? Router A will generate a broadcast. Okay, router A will generate a broadcast. This time the destination IP will remain 20.20.20.3. The source IP will remain same, but the source MAC address will be the WAN interface MAC address of A, which will be 000.000.000.000.001B. Okay, so this broadcast and destination MAC address will be again FF, correct? Because even router doesn't know how to reach 20.20.3, so it is broadcasting. This broadcast is received by B. So what B will do, it will stop that broadcast over there and it will tell A that okay, I will help you to reach to B, but what you do, you accept my MAC address as a MAC address of B. Basically B is also proxying the MAC address of B. Okay, so now this will change to the MAC address of the WAN interface of B, 000.000.000 to B. Okay, now B will stop this broadcast over here itself and it will generate a new broadcast on this LAN interface. So again the source IP will remain 10.10.3, destination IP will remain 20.20.20.3, but source MAC address will become the source MAC address of LAN interface of router B. LAN interface of router B, which will be 000.000.000.000.2A. Okay, and the destination will be FFFFF, destination MAC address. When B receives this packet, what it will do? It will respond back. Now when B responds back, what will happen? Let's see. Now when B responds back, so B's source IP address will be 20.20.20.3, destination IP will be 10.10.3, source MAC address will be its own MAC address, which will be 000.000.000.000.2A. Okay, and destination MAC address will be the LAN interface of B, correct? Because B is proxying the MAC address, correct, of A. So it is proxying the MAC address of A, so it will be 000.000.000.000.2A. Now when the router B receives the ARP response, okay, it will forward this response to A. Again what it will do, it will change the source MAC address to its own WAN interface MAC address, okay, which will be 0.000.000.000.2B, and destination MAC address will be the MAC address of A, correct? So which will be 0.000.000.000.000.1A. Now once the A receives the ARP response, it will forward that packet to machine A with the source MAC address as its LAN interface MAC address, correct? LAN interface MAC address. and the communication will complete. So this is how it will happen at layer 3 if routing protocol is not enabled on the WAN interface. Okay, so you need to enable IPR broadcast on the WAN interfaces of router A and B. If you don't enable the IPR broadcast, then this communication will remain incomplete. Okay, if you see the ARP cache of both the A and B, it will show incomplete. Okay, so you need to enable IPR broadcast on both the router A and router B. But in practical scenario, such kind of you will never see IPR broadcast enabled because you have a routing protocol enabled. Routing protocol will take care of routing the packets. Okay, it will resolve the next hop. Hence, you don't need a broadcast. Okay, it's a security loop if you enable the ARP broadcast. Also, it will consume lot of CPU and memory. Okay, every time the router has to broadcast the packet, and again the MPLS, the service provider which is providing you the service, will not allow the broadcast to forward, will not forward the broadcast. So in practical scenario, you will not see such kind of in practical you will not see such kind of scenario. Okay, you will have a routing protocol which will do the routing of the packet. So basically, ARP resolution will have ARP will come into picture only on the LAN side. Okay, so now here you also need to understand what is the gratuitous ARP. What is the gratuitous ARP? Normally, what happens is when a machine comes online, it sends a gratuitous ARP with its own IP address as a destination IP address, and it's a broadcast. Okay, so what happens the moment it sends the broadcast with its own IP address as a destination IP address, so everybody and the source MAC address as its own MAC address. So everybody, every machine in that LAN will come to know about its about the MAC address, and if suppose there is any duplicate IP address, okay, in the LAN, immediately it will be reported. Okay, so sometimes you might have if it's a DHCP and the DHCP pool is exhausted, and if somebody tries to put a static IP which is already used by DHCP, then you will see a pop-up message that about the duplicate IP address. It is because of that only, gratuitous ARP. So when again when the router receives that gratuitous ARP, router will it will store its store the MAC address of that machine in its cache, and machine will also store the MAC address of the router in its cache. Okay, the first thing that will happen because of the gratuitous ARP. So yeah, in the live environment you will see the IP broadcast, and that IP broadcast is immediately responded by the router A with its own MAC address. Okay, so that's it about the ARP, how it works at layer 3, on layer 3. And there is an important concept of default gateway. So what is a default gateway? Basically, if a machine wants to reach out to any IP address which is out of its subnet, okay, and if that machine doesn't have any other way to reach or any other route to reach that machine, then it will go to that IP address or to that device which has that IP address. That is called as default gateway. For example, in a room, okay, you have one door. If you want to go out of the door, if you want to go out of the room, you basically will go to room, unless that room has a separate window, there is another route by which you can go out. Okay, so the door of that room is a default gateway. So similarly, in the networking world, we have concept of default gateway. Okay, if there is no other exclusive route for a particular destination, then the machine will try to reach the default gateway if it is configured on the machine. So let me just show you how we configure. You can see IP config. Okay, on the command prompt, you can see the IP config, and let's see. If you go to command prompt, IP config, here you will see the default gateway. See, this is the default gateway. IP address subnet mask. As I told you earlier, using the IP address and the subnet mask, the machine comes to know to which network it belongs to which subnet it belongs to. Okay, and if you want to see show ARP, or maybe ARP, so IP ARP, show how do you see this? ARP minus A, yes, ARP minus AC. It has resolved the default gateway's MAC address. It has put it into the cache table, and it is dynamic. If there is no communication happening for a long time between the machine and the default gateway, that ARP cache entry will be, it might get removed. Okay, so I will explain you what is this 1.255 and what are these 224 when we cover the subnetting topic. So yeah, before I wind up, I just wanted to tell you that the ARP cache entry inside in the machines can get timed out if the machine does not communicate for a long time. Also, the MAC address table in the switches can get aged out or flushed out after max age time. Okay, if there is no communication happening. Same thing is true with the routers as well. Okay, so that's it. Thank you. I hope the session is useful for all of you. This is a very important concept of address resolution protocol, and it is asked in the interviews like Cisco, Google, and Amazon. They try to test if you know the basic how the communication happens between the two machines at layer 2 and layer 3. Thank you all. Next time we will cover the TCP and IP. Bye.